We prove this by a mathematical induction. Okay, now n is positive integers. Okay, this is a proof. Okay, now first, when n equal to 1, the left hand side is equal to the derivative x with respect to x. That's equal to 1, right? It is true. The right hand side is equal to 1 times x 1 minus 1, which is also equal to 1. Therefore, it is true. So it is true for n equal to 1. Okay, that is the first step. Then assume it is true for n equal to k. Then that is namely the derivative of x to the power of k is equal to k times x to the power of k minus 1. Okay, then the derivative of x k plus 1 that would be equal to the derivative of k to the power of k times x. Now then, by the product rule, it is equal to the derivative of x to the power of k times x. Okay. Plus the x to the k times the derivative of x with respect to x. And this one is equal to, according to the assumption that this one is equal to k times x k minus 1. That is assumption times x plus x to the power of k excuse me, that is the n equal to 1, right? So this is equal to 1. So we have k. This time this one is x to the power of k plus x to the power of k. So this one is equal to k plus 1 times x to the power of k. Well, so that means that true for n equal to k plus 1. Okay. Therefore, so we prove that, therefore, the derivative of x to the power of n is equal to n k plus n minus 1. So that's we proved. So that is the way of the power rule when n is positive integer is true by using the mathematical induction. Let's prove this one. Prove the excuse me, my throat. Okay, the integral x to the power of n dx is equal to n plus 1, right? And x n plus 1. While n is a positive integer. We also prove by mathematical induction. Okay, the proof. First, we let when n equal to 1. So when n equal to the left hand side is equal to integral x dx. Well, that integral, of course, is equal to half x squared, right? Plus c. Now the right hand side is equal to 1 plus 1 and x 1 plus 1. So this, so I forget a c, yeah? Plus c, yeah. Plus c is equal to half x squared plus c. So this means that it is true. So it is true for n equal to 1. It means this, right? Now then, assume it is true for n equal to k. Well, it means this, right? The one we want to prove. That is for mathematical induction. The writing is very well strictly logical. So this means that the integral x to the power of k dx is equal to 1k plus 1 x to the k plus 1 plus c. This is just assumption. Assume this is true. Then the integral x k plus 1 dx, then this is equal to well, obviously this is equal to x to the power of k multiplied by x and the dx, right? Yeah, then this one is equal to, well, how should I write? I'll write this one. I write x to the k dx. Yeah, okay. Then, according to my assumption, x to the power of k dx is this. So that means this derivative is this. So which means x times the derivative of k plus 1 x k plus 1. Yeah, this derivative is equal to x to the power of k by assumption. So we can use by parts, right? This is u, this is v. U dv is equal to u times v. This is this, k plus 1, minus integral v du. V is this, x plus 1, x to the x plus 1 times du. Du is a dx. Okay. So this one is equal to k plus 1. This will be x to the power of k plus 2 minus 1 over k plus 1 x to the power x plus 1 dx is what my integral to start with. So this is I, right? This is I. So this is my original integral. Then I move this one over there. Therefore, I plus k plus 1 is equal to k plus 1 x k plus 2. Yeah. Then multiply by this one. Then this will be k plus 1, this k plus 2i, right, is equal to k plus 1 x k plus 2. So I is equal to, by multiply k plus 1 both sides. Yeah, so this is equal to k plus 2, right? And the x k plus 2 plus the constant. See, that is I don't have a room to write, so I should write that it is true for k plus equal to 1. Sorry. It is true for n equal to k plus 1. Therefore, it is true for all n. Okay. Okay. So, excuse me, there's no room for it. First, I let n equal to 1. It is true. When we assume, after we assume that it's true for n equal to k, we prove that it is also true for n equal to k plus 1. Therefore, this is true for all n. Well, thank you for your watching.